Okay, in this video I'm going to go over how to write enthalpy of combustion reactions, or standard enthalpy of combustion reactions, sometimes called heat of combustion reactions. So the standard enthalpy of combustion is the energy change that occurs when 1 mole of substance reacts with excess oxygen under standard conditions. So what does that mean? Well, here's an example. Here's methane here, and I've drawn it plus reacting with oxygen, and that's O2 gas. It will produce carbon dioxide plus water, and it's going to release some energy. So here's some energy written on the right hand side. Now, combustion equations, exothermic reactions, we're going to expect them to be negative on the right hand side. But in this video, we're not looking at the energy changes so much as how do we write a correct equation. And the very first thing we need to know before writing the correct equation is, okay, if we have the fuel, what are the oxides that are made from the different elements in the fuel, or the different atoms? So if there's a carbon in the fuel, it's going to make a carbon dioxide. If there's a hydrogen, it will make a water liquid. So carbon dioxide gas. The phases are really important to write in these equations. We've got water liquid. And then sulfur is going to make sulfur dioxide as a gas, or nitrogen dioxide as a gas. We're most probably not going to use the sulfur or the nitrogen ones. In the examples I give, we're just going to have carbons and hydrogens. Really important, carbon goes to carbon dioxide gas, hydrogens goes to water liquid. Okay, so let's have a look at an example of a combustion equation. So we want to write the standard enthalpy of combustion for propane gas. So the very first thing we're going to do here is we're going to write the reactant. We're going to add oxygen gas, okay, because remember, combustion is the reaction with excess oxygen gas, so that's always present on the left-hand side. So we've got the fuel plus the oxygen gas, and we're going to produce the arrow. Now what we're going to work out, what we're going to make now is we're going to look at our fuel here. We see that there are carbons and there are hydrogens. So the carbon is going to make a carbon dioxide gas. There we go. And the hydrogens are going to make water liquid. So here are all of the components of our equation, but they're not balanced. And in order to balance this, we now need to put coefficients in front of the oxides on the right hand side. So in front of the carbon dioxide and the water. Now if we look on the left hand side, we can see that propane has 3 carbons. So I will need 3 carbon dioxides in order to obtain 3 carbons, right? Or to balance it, to make it equal. And in order to have 8 hydrogens that are on the left-hand side, on the right-hand side, I need to make 4 water molecules, because each water molecule has 2 hydrogens, so I need 4 times 2 is 8 hydrogens in total. Now, because I've put coefficients in front of the carbon dioxide and the water, I've got quite a lot of oxygen atoms on the right-hand side. So I've got 4 water molecules that have 1 oxygen each, that's 4 oxygens. Plus, I've got 3 carbon dioxides that have 2 oxygens each. That's 6 oxygens. So I've got 6 oxygens plus 4 oxygens is 10 oxygens in total on the right-hand side. So I need 10 on total on the left-hand side. And the only thing that provides the oxygens is the O2. I need 10 oxygens, so I need 5 O2s here. And the last step is to put the coefficient in front of the oxygen gas. Second last step, coefficients in front of the oxides. Okay, let's have a look at this. Once we kind of know these steps, let's go over them real quickly. Write the reactant, oxygen gas, and the reaction arrow. Identify the oxides, write them down on the right-hand side. Write the coefficients for the oxides, usually carbon dioxide and water, and then we write the coefficients for the oxygens. So this one here is ethanol. So there's a particular example. The reason I chose ethanol for you here, because I want to show something. So for a start, we're going to write down the fuel here. It's ethanol. We're going to add the oxygen gas and the arrow. Now we can see here that there is a carbon, there are oxygens, hydrogens, and the oxygens. Of course, the oxygen isn't going to react with oxygen to make an oxide, because it doesn't do that. So we've just got carbons to make carbon dioxides and hydrogens to make water, and we're going to ignore this oxygen. It's going to be it's important to notice it, because we're going to use it when we do the balancing in the equation, but it's not going to create anything unique by itself with the oxygen, because it would just produce oxygen, right? So we have 2 carbons on the left-hand side, so we're going to put a 2 in front of the carbon dioxide. We have 5 plus 1, 6 hydrogens on the left-hand side, so we're going to put a 3 in front of the water. And now we're going to add up the total amount of oxygens on the right-hand side. So we have 3 waters, which is 3 oxygens in total from the waters, and 2 carbon dioxides, which is 4 oxygens from the carbon dioxides. 4 plus 3 is 7 oxygens on the right-hand side. However, on the left-hand side, even though I need 7 oxygens, I need to realize that there is an oxygen in the ethanol already, so that's accounted for one of my oxygens. So I need 7 oxygens in total on the left-hand side. I have 1 in the ethanol, so I need to get 6 from the oxygen gas, so I need 3 oxygen gases. And now that is a balanced enthalpy of combustion equation. Okay, now you've watched me do this, let's go to the... Right, so now that I've gone over how to write combustion equations, it's your turn to have a go. So just on the right hand side, I've got the atoms and the oxides they form. Use that to write the combustion equations for this table. So what you'll need to do is pause the video, write the answers to the equations, and then start it again, and I will go over the answers. Okay, so hopefully you've answered these. The first one we've got here is combustion of carbon. It reacts with oxygen to produce carbon dioxide. The next one is butane. Notice with butane, we had 10 hydrogens, that's 5 waters, and we had 4 carbons, that's 4 carbon dioxides. When we add up the total number of oxygens on the right, there's 13. So in this case, is going to be a fraction, 6.5 oxygens. The next one is propanol. The thing to note about this one is that you need to make sure that you've counted, 3 oxygens here plus, 6 oxygens plus 4 is 10 oxygens. So we have 10 oxygens. We need to account for them on the left hand side. We've got 1 already in the propanol, so we need 4.5 O2s. The next part is hydrogen. Well, it just makes water, so it's going to have half an oxygen to make water. And the last one is ethene. And ethene is ethine, sorry. That's a triple bond in there. So we've got 2 carbons, so we're going to make 2 carbon dioxides, 2 hydrogens, 1 water. That gives us 5 oxygens in total, which is 2.5 oxygens. And those are the combustion equations. Hopefully this has helped. Look out for the other video I have on how to write formation equations, enthalpy of formation. Good luck.